Assalamualaikum warahmatullahi wabarakatuh and good evening to the lecturers. We are from Group 12 and we will be presenting our Manova project, which is a project we did for our subject ECC 3014 and ECH 3119. Our Manova project is entitled Distance Travel by Toy Car and Time Taken for Toy Car to Stop with Different Factors. Before we move on, I would like to introduce my group members. Firstly, my name is Nurmai Sarah and my matrix number is 196309. I am the leader of the group. And next we have our experimental members of the group, which is Nur Afifah Dila and Nur Aina Nabila. And then our computational member of the group, which is Kashutran and Amma Abdullah. So next, this is the table of contents of our presentation today. We will be covering four main topics, which is our objectives and variables, and then experimental results, data analysis, and finally conclusion. So next is, firstly I will tell you the objective of the experiment. So for our experiment, the first objective is to measure the distance traveled and time taken for the car to stop when the toy car is released from different inclination angle of surface. The second is to measure the distance traveled and time taken for the car to stop when the toy car is pulled from different distance towards starting point before release. And then the third one is to measure the distance traveled and time taken for the car to stop when different weight of load is used on the toy car. Our responding variable is the distance traveled and time taken for the car to stop. So next, we're talking about the factors or the variables in this experiment, and I'll pass on that to our experimental member, which is Aina.
Hi, Assalamualaikum. My name is Nuraina Nabila binti Ahmad Rizi. Matric number is 199141. So I'm going to discuss about the types of variable that our group have been used. We use three manipulated variables, which is the weight of load, distance pulled towards starting point, and the inclination angle of surface. And we are going to have two responding variables, which is the distance traveled by the car and the time taken for the car to stop. Okay, next we will discuss about the experiment result. The first table is about the result of the distance traveled by the toy car, which is the first responding variables, and the second one is about the time taken for toy car to stop, which is the second responding variables. So based on the result, the distance traveled by the lighter car is more than the heavier car. The second one is the distance traveled by the car is when going to the high inclination angle, which is at the 45, will be the higher than the will be go more further than the lower one, which is at the 30 degree. And lastly, the distance traveled by the toy car when pulled in 10 cm towards the starting point will be go more further than the other one. So for the table 2, the result is for the time taken for the toy car to stop for the heavier one. For the heavier load is shorter than the other one. And the height of angle inclination will take more time for the car to stop, including when the distance pulled towards in 10 cm from the starting point. It will take more times to stop too.
Hello, I am Ammar. My matric number is 199664. So first of all, I'm gonna talk about the descriptive statistics. We've got these two tables from our experiment describing the time taken and also the distance traveled. The parameters that we have here are the mean, standard deviation, as well as the population. So for the time taken here, we have both weights, 50 grams and also 100 grams. Also, the other table describing the distance traveled, we have both weights, 50 grams and also 100 gram. And also we have the parameters here, mean, standard deviation, as well as the population. We've got these data. The second thing that I'm gonna talk about is the grand mean. We have got this table from our experiment, describing the time taken and the distance traveled regarding the mean, standard error, as well as we have the confidence interval. It's about 95%. Also here this table describing the lower and upper bound. So these data, these data that we've got from our calculations. Finally, we have null hypothesis and alternative hypothesis. So what are these? The null hypothesis, it is a hypothesis that states there is no statistical significance between variables. So initially we use null hypothesis, but sometimes we use alternative hypothesis. When we use it, when we reject the null hypothesis. So I think this is all.
Null hypothesis, the mean for the distance traveled by toy car and the time taken for a toy car to stop is the same for each weight of the load, which is the 50 gram load and 100 gram load. Secondly, the mean for the distance traveled by the toy car and the time taken for the toy car to stop is the same for the each inclination angle of surface, which we use is 30 degree and 45 degree. Thirdly, the mean for the distance traveled by the toy car and the time taken for the toy car to stop is the same for each distance the toy car pulled towards the starting point, which we used was 5 cm and 10 cm. Thirdly, the box test. The box test is the test of equality of covariance matrices. It tests the null hypothesis that the observed covariance matrices of the dependent variables are equal across groups. The confidence level is 95% and the alpha is 0.05. The p-value we obtained was below 0.005, hence the null hypothesis is rejected. So the box M that we obtained was 53.212. The F value we obtained is 1.822. The degree of freedom for both 1 and 2 we obtained is 21 and 2064.623 respectively. And the significance value we obtained is 0.013. So lastly, we move on to the multivariate test. The multivariate test is the effect of the weight, inclination, and starting distance which affected by Wilks lambda. So the value we obtained are 0.991, 0.164, and 0.593 respectively. So here we can see the box test, which are the F value, the hypothesis of degree of freedom, the error for degree of freedom, the significance value, the partially ETA squared, non-standard parameter, and the observed power. So from here we can say that the matrices are equal across the groups.
Assalamualaikum, my name is Rafi Fadila binti Dewi and my matrix number 188692. Let's continue with the presentation, and based on the previous explanation, the results analysis should be based on the Wilks lambda test statistic, and this is because the box test is found to be disadvantageous in this experiment due to the small sample sizes and the assumption that the data is normally distributed. Based on the Wilks lambda table, the p-value found for these two variables, which is the inclination angle and the starting distance, are both below 0.05, hence the null hypothesis for these variables are rejected. However, for the weight of load, the null hypothesis is accepted. Now let's look at the first two graphs. It can be concluded that as the inclination angle increases, the time taken for the toy car to stop will also increase. Referring at the first graph, it is shown that by using 50 gram weight of load at starting distance of 5 centimeters, the produced estimated marginal means is much higher. But when using at starting distance of 10 centimeters, the produced estimated marginal means for 50 gram weight of load is lower. Looking at the next two graphs, it can be concluded that as the inclination angle increases, the distance traveled by the toy car also increases. Looking at the second graph, when using 100 gram weight of load at starting distance of 10 centimeters, the produced estimated marginal means has shorter range, but it starts at a much higher value than when 50 gram weight of load is being used. In In a nutshell, increasing the inclination angle of the surface and distance of toy car pulled towards the starting point will cause the distance travelled by the toy car and the time taken for the toy car to stop to also increase as well. The weight of load does not affect the distance travelled by the toy car and the time taken for the toy car to stop as much. That is all for our presentation. Thank you and have a nice day.